a different aspect of calculus when it comes to linear function. So here we have the graph of the linear function g is shown below, and we can see a straight line. Okay, perfect. So what do we need to do with that? Use the graph to find the rate of change of g of x. Now, even if you didn't know, they are telling you that is what we are saying here, that is find that. What is that? Derivative of g. Because rate of change is another word for derivative. Why? Because derivative talks about a change of a line. It gives it a value, it gives it a rate, that's what that word means, but it basically defining how our line is changing. And then they are saying, give your answer in the form A over B, where A and B belong to natural. But how do we solve that? So basically, they are saying, find the derivative of G. Now, the knowledge that we need to use here. Well, first of all, let's take an example of any linear function. I'm not saying that is the function, I'm just making that up. So let's say that's our function. Let's say that's a linear function. If we were to create a derivative of that, we know that a number that doesn't have x beside it goes into 0. And then when I have x with power of 1 or no power, derivative of that is the number that stands beside x. In this case would be 7. So derivative of this function y would be 7. Now, at the same time, when it comes to linear function, what is that 7? That 7 is the slope. Because value of slope at a very specific point, I have to add, is the same as value of derivative. Again, at that same value of x. Okay, so this is the knowledge that we are applying here. When they are telling us to find the derivative of this linear function, would be just a number, we understand that, in other words, we can find the value of the slope. If we had g function, we could create derivative, but we don't have. Can we get it? Yeah, we can get it. We have pretty good graph. We can get the information. But really, all we need from that function, from that g function, is its slope. How do we calculate the slope? In our maths tables, we have a formula, coordinate geometry. Where is that? There it is. We have a formula for the slope. So what do I need in order to calculate the slope? Well, I need 2 points, isn't it? How do I get 2 points? In this case, I can look at my graph and take any 2 points that are really well readable. So for example, I can see that this point is well readable, that is 3, and that is 3. And then, for example, another point, this one here, that will be 1 and 0. So 1.0 value of x and 1 for y, and then the other one 3 and 3. Let's say, for example, that's the point we can pick. So that means the slope of this function will be, let's put that is x1, y1, x2, y2. So y2 is 3, 3 minus y1, and my y1 is 1. And at the bottom, x2 is 3 minus y1, and y1 is 0. So we put that in the calculator and we get the value of 2 over 3. And yes, we have the slope. At the same time, that slope is derivative of this function, and it is given in the form of the fraction, where a number on the top, our 2, belong to natural whole numbers, positive, that's what we have, and b, number at the bottom as well belong to natural, and that's our 3, and indeed, that number belong to natural. So we fulfill the terms and condition of our answer.